This topic is about formulas. Height versus node formulas. So what is this? If we know the height of a binary tree, what could be the minimum number of nodes and what could be the maximum number of nodes? And vice versa. If nodes are given, what could be minimum height, what could be maximum height? We are going to discuss this one. So first, let us learn if height of a binary tree is given. Then what could be the minimum number of nodes, what could be the maximum number of nodes. So already I have taken few examples. Let us study these examples. Height of a binary tree is given, height is 1. So height starts from 0, right? So this is 0 and 1. So height is 1. So in height 1, minimum how many nodes are required to reach height 1? 2 nodes. If I remove a node, then only one node, it will not be height 1. So minimum 2 nodes are needed to make a tree of height 1. Then in that height 1, maximum how many nodes are possible? 1, 2, 3 nodes are possible. Now likewise, if height is 2, then for making a tree of height 2, minimum how many nodes required? 1, 2, 3. Maximum 7 nodes. Likewise, height is 3, minimum nodes these many, maximum nodes this many. We don't want a count, we want a formula. So from observation we can generate the formula. So first let us check minimum number of nodes. If height is 1, minimum 2 nodes. Height is 2, minimum 3 nodes. Height is 3, minimum 4 nodes. So minimum nodes formula will be height plus 1. See, height plus 1. So minimum nodes n equal to h plus 1. This is one formula we got. Now we want the formula for maximum nodes. 3, 7, 15. We don't find any pattern. Like there was a pattern here, height 2, so 3, height 3, so 4, so height plus 1. But 3, 7, 15, let us observe from this tree. How we got 15? We got 15 because this is one node, and in this level there are 2 nodes, and in this level 1, 2, 3, 4 nodes are there, that is 2 square nodes, and in this level 1, 2, 3, 4, 5, 6, 7, 8, 2 cube nodes are there. So this is 1 plus 2 plus 2 square plus 2 cube. This answer is 15. So all these nodes when they are added, it is becoming 15. So 1 plus 2 square plus 2 cube is giving 15. So is there any formula for this one? Let me show you the formula. See, this is GP series, AR, AR square, AR cube, so on to AR power K. So this is GP series and all the terms of GP series are added. So sum of the terms of GP series, that is geometric progression. Sum of the terms of GP series means geometric progression series. So there is a known formula for this one. This is A r to the power of k plus 1 minus 1 by r minus 1. This is a known formula. Now this looks like GP series only. Let me write down that one. See, I have written this one. 1 plus 2 square plus 2 cube goes on till 2 power h. Then what is A in this one? A is 1. Then what is R in this one? R is 2. See, for each term coefficient A is not there. Not there means it is 1. So A is 1 and R is 2. So I will use this formula and I will write down A as 1 and R as 2. So this is A is 1. R is 2 power, what is the maximum term I have taken? H plus 1 minus 1 by R is 2, so 2 minus 1. So if I simplify this, this is 2 power H plus 1 minus 1 divided by 2 minus 1 is 1. So that is the answer. So if you take the sum of these terms up to H, then this is 2 power H plus 1 minus 1. Let us come back to this example. Height was 3. So 1 plus 2 square plus 2 cube up to 3. Height 3. So this is nothing but 2 power h plus 1 minus 1. So 2 power 3 plus 1 minus 1. Let us put the values here. So 2 power 3 plus 1 minus 1. This is 2 power 4 minus 1. And this is 16 minus 1. So this is 15. Yes, it is correct. It is correct. So that value 15 is sum of the terms of GP series. So these are some of the terms of GP series. So these are GP series terms. If we take maximum nodes. So that is similar to this one. We already know the formula. We have used the same formula. Now we got the formula for maximum nodes. So we already have for minimum nodes. I will remove this. I will write down for maximum nodes. So formula for maximum nodes, n equal to 2 power h plus 1 minus 1. So now we know the formula. If height of a binary tree is given, then within that height, minimum we need h plus 1 nodes, maximum 2 power h plus 1 minus 1 number of nodes are possible. Alright. So these formulas are very important for binary tree. Now I need the formulas in other way. If nodes are given, what will be the minimum height? What will be the maximum height? Here we know height, so we found out nodes. Now next we will be knowing nodes, we want height. So I think same formulas we can use. Let us see. First I will take some examples, then we will discuss this. Now if the number of nodes are given, we have to find out what could be the minimum height, what could be the maximum height for those number of nodes. So here I have already taken some examples. Using 3 nodes, I can generate a binary tree of minimum height 1, 0, 1. And with that same 3 node, I can stretch the height up to maximum 2, 0, 1, 2 for 3 nodes. Next, I have taken an example of 7 nodes. So for 7 nodes, 1, 2, 3, 4, 5, 6, 7, this is the minimum height. Height is 2. That is 0, 1, 2. And these 7 nodes, maximum height is 6. Then for 15 nodes, minimum height is 3, maximum height is 14. Now we want the formula for minimum and maximum. First of all, we will find the formula for maximum. Let us check maximum. Maximum height for 3 nodes, height is 2. For 7 nodes, height is 6. For 15 nodes, height is 14. So there is some pattern. Whatever the nodes are, height is 1 less than that. Nodes are 7, so height is 6. Nodes are 3, so height is 2. So height is 1 less than the number of nodes. So yes, we got the formula for maximum height. So maximum height formula, h is equals to n minus 1. We got the formula. Now what is the minimum height formula now? If I check the minimum height, number of nodes are 3. So minimum height is 1. Number of nodes are 7. So minimum height is 2. Number of nodes are 15. So height is 3. So I don't find any pattern here. So I'll show you something here. See, these are the formulas just now we have found out. If height is given, then minimum nodes and maximum nodes. We have already written the formula. Minimum nodes n is equals to h plus 1. Maximum nodes is equals to n is 2 power h plus 1 minus 1. We have seen this formula. Now, we are finding out now if nodes are given, then find out minimum and maximum height if nodes are given. So for that, maximum height we got h is equals to n minus 1. So that's similar to this one. H is equals to n minus 1. H is equals to n. This plus 1 you send it there. So minus 1. So this was the minimum nodes formula. It became maximum height formula. So it means maximum node formula can be converted into minimum height formula. So I don't have to observe from the trees. Let us use this formula and convert it. Okay. So what is the formula? N is equals to 2 power h plus 1 minus 1. So I will find out here. N is equals to 2 power h plus 1 minus 1. This is the formula, right? This is for maximum nodes. So this I can write it as n plus 1 is equals to 2 power h plus 1. That minus 1 I brought it here. Then I will change the side. So 2 power h plus 1 is equals to n plus 1. Now h plus 1 is log base 2 n plus 1. So if you send this base, that side it becomes log. So h plus 1 is equals to log base 2 n plus 1. Finally, this h is equals to log base 2 n plus 1, and this plus 1, if I send it there, minus 1. So I got the formula for h. H is equals to log base 2 n plus 1 minus 1. From where I got this one? From this one. See, from this formula, this was in terms of h to find out n. I converted it in terms of n to find out h. This is the answer for minimum height. Minimum height. So if n nodes are given, the minimum height will be based on this formula. Let us verify this one. See, I am having 15 nodes. What could be the minimum height? We know the answer 3. Let us check it. H is equals to log 15 plus 1 minus 1. So this is log 16 base 2. Log 16 base 2 minus 1. Log 16 is how much? 4 minus 1. This minus 1 as it is. This minus 1. This is 3. Yes, we are getting the answer. So from these formulas, we can derive other formulas, right? So if you know the formula for height, you can get the formula for nodes. So I will write down those formulas. H is equals to n minus 1. H is equals to minimum formula, that is log base 2 n plus 1 minus 1. Maximum formula n minus 1. So we got the formulas. So I will remove this and finally show you two formulas. These formulas, I'll show them here. Finally, from the observation, we got a range of values. See, first formula we saw is this one. Number of nodes in a binary tree. Number of nodes. Minimum h plus 1, maximum 2 power h plus 1 minus 1. This is based on height. If you know the height of a binary tree, then in that binary tree, minimum number of nodes can be these many, maximum number of nodes can be these many. Next, we saw this formula, height of a binary tree. This is very important. Height of a binary tree can range from log n to n, logarithmic to linear. Then this is order of log n, and this is order of n. So minimum is log n, maximum is n. So height of a binary tree can range from log n to n. Remember this one always. So binary tree means log n to n. Whatever the board work I have done, you do it once, then you will always remember these formulas. These formulas are very important.